My name is Daniel Huszár. I'm head of sales at FCOM, I think. There's one slide before that. Yes, this company. We provide a factoring platform, and we are a very old fintech, 20 years old, so a bit of old world, a bit of new world. And today I will talk about AI, artificial intelligence, and how it can help with SME banking, but I take a very broad approach at this. So that we actually, what we learned, and we don't have a finished product with this yet. So you can go with us to this journey and see, get your own ideas also with this presentation. And because, AI is everywhere as of now. Basically, maybe you have Siri, maybe you have Alexa, maybe you have Google Assistant. You saw these nice, when you this text-to-speech translation of Google Assistant, when it kind of tries to understand you, and you first panic because you said something completely different. I'm not sure if you ever saw that. And then out of the context of the words, like magically it appears in any language, what you just said, and makes a Google search for you. Or when a Spotify playlist has been catered to your taste, for example, that's also AI at work. And so the questions that I'm asking, for example, the most important question is, will the robots take over? No, really, will they? I'm not sure if they will, but by the end of this presentation, I think you'll be surprised about the paradigm shift that happened in AI in the last 10, 20 years, in the last 2 decades, which I think is very exciting, like computers actually learning and building a brain inside a computer, for example. And I'm going to take you on a journey now, way back to 1997, which maybe some of you will remember this game against, that was IBM's Deep Blue. So not the guy, he's just part of the team. Deep Blue is an AI. And Garry Kasparov on the left. And this was actually the year that Kasparov lost the first time, 1996, he won against this AI. And yeah, it's a very, it was very hard, I guess also for him to lose against the AI. It was the first time that at this complex game, and AI beat the grandmaster, the world champion of chess at that time. So the question is, how did they do this, and how is this different of what we do today with AI, like Google Assistant, for example? So they used sheer processing power to basically overpower a human with his thinking, because you know that really good chess players, not even grandmasters, they can think several turns ahead. Well, an AI uses the same method of decision trees, right? You kind of, in the game of chess, you kind of look ahead and say, what will be the most profitable move to kind of close the game, and analyzing win rates. The thing is, an AI can analyze every possible move, because Deep Blue could analyze 200 moves a second, 200 million moves a second, I'm sorry. And so it was able to make the best move always, and with this. Considering every possible move, and as a plus, this team was allowed, the IBM Deep Blue team was allowed between matches to kind of reconfigure and reparameterize the AI. So which kind of, I mean, it's a bit unfair, and we will see some similarities with financial products that we are using with parameterization by humans. So what the gist of this is this was an extremely good, extremely good AI, and a great accomplishment at that time. But was the AI really learning? It was a combination of processing power and very smart people doing this, and the brute force of this AI going through every possible calculation. But today things look a little bit different with the AI, let's say. Doesn't change. 2016. March 2016. This was the challenger game, Go. It's not so well known, so I will just explain very briefly the basics. So the goal is to have more stones on the board than your opponent by the end of by the end of the game, and if you can encircle your opponent's stones with your own, then these stones get removed, so they get trapped. They get kind of trapped. So this is a very old game. This is 2,500 years old, and the challenge of this game is this has been deemed as impossible by data scientists. Is that, well, it has always has 10 to the power of 172 moves, which is more than atoms in the universe. These are the possible moves at any given time. So this game cannot be solved by brute force. No computer can go all possible iterations of this. Maybe ever, maybe quantum computing, I don't know. But so there had to be a different approach, right, to do this. And this was found with a company called DeepMind, which were acquired by Google at that time, and they created an AI called AlphaGo, and which played this guy, Lee Sedol, from South Korea. He is 18-time world champion at the game Go, so he is a bona fide genius at this game, absolutely, and was deemed unbeatable, and he was very confident that he would beat the AI 5-0, and then he lost the first game, which was deemed kind of a fluke, and he lost the second game, and he lost the third game. He won the fourth game, and he lost the fifth game. So he lost 4-1 against this AI. And the funny thing is, or the thing that he remarked after this is that he was absolutely impressed that it was like behaving like a human, and it was creative, and the AI made like bad moves, let's say, moves that the human would never make, but were still creative and led to a win that 1 out of 10,000 skilled players would never have made, maybe an amateur, and everybody would have thought it as a mistake. And he said, okay, it's not important why I lost all these games now, but how did I win this one game? And it was because, and you could see it, there's a documentary on Netflix if you're interested, you could see that the AI taught him new things about this game that he mastered, that he's a complete master at this game, about this 2,500-year-old game. And after that, he didn't lose one match for, I think, 3 months or something like that in tournaments, because he applied this new knowledge and probably overpowered and confused his opponents completely. Yeah. And so how did they do this? They used a technique which is, because it can't be solved by brute force, so we can't go through all the calculations, so we need to do something different. And they took an approach, it's called machine learning and deep learning. And why deep learning? Because, well, I'm going to briefly summarize, because it's quite a complicated subject, but it's many layers of so-called neurons, and they kind of generate inputs and outputs. So this AI analyzes games. Yeah, it really plays the games and analyzes them. It analyzes moves. This is the bottom layer, for example, one move, another move. Then on a layer, it has a certain board state. You saw the black and white stones, so it will look at part of the board and try to say, is this a good board state? Is it a bad board state? Just like math questions, is this good? Is this bad? Is this right? Is this wrong? And then it will play games against, or will analyze games of maybe amateur players, just to imitate these moves and to imitate these board states. And then it will go further and be shown data of better players, and it will play against itself over and over and over again and learn, just like a human brain. So this is much more similar to a human brain, and even though it also uses, for example, decision trees, but it cannot go through every branch to analyze what a good play is. So just like us, when we go through decisions, we don't take every decision into account. It would be crazy. You know, I could jump off that building. That's not a decision tree that's in my mind, right now. Yeah, but there are a limited amount of options, and so an AI can learn through deep learning what the best limited options are, and then pick the best one from this reduced set of possibilities. Let's say. So yeah, that's a brain. So the thing is, I talked about a paradigm change, and it's about developing. Now we humans, we tell the computer through code what to do and maybe what not to do. But this is kind of, and this is an approach called training. When you show these games over and over again and let it play against itself, it kind of writes itself. And this is not, I don't know, this is not futuristic. This is not some faraway thing. This happened in March 2016. So this is all over. This is happening right now, and there are lots of companies that have code that writes itself and makes itself better, improves itself over and over again. And maybe to finish the story, there's now a new AI, which is the new Go World Champion, which is called AlphaZero, and it won 100 to 0 games against the AI that beat Lee Sedol, the Korean World Champion. So this is just the improvement is crazy. Just in a couple of months, yeah, by playing against itself. So let's jump to now. And now I'm actually gonna talk of one of our products that we use right now. It's a risk module. So I mentioned we do factoring. So this is about invoices, financing invoices, and putting them in your inventory. And with this risk module, we can actually, because we have a very deep data depth, we can actually tell if this invoice is fake or not. Yeah, we use lots of parameterization to do this, looking for patterns. Yeah, if you make up invoices, for example, you try to defraud a bank, for example, the numbers and the amounts, they won't be so streamlined. They won't align to a bell curve, or maybe you have a preference for the number 2 or something like that. Maybe the invoice was posted on a weekend, yeah, and the numbers don't match up. And we can also compare the client's behavior from today to and compare it to his behavior from 180 days ago, or 30 to 180 days. So we can look for patterns. But the thing is, with these, we put in all this big data, and we have annually 100 million invoices going through this process alone. The thing is, this is still the Kasparov approach, if you think about it. This is great, and it's working really well. Yeah, this is super. But it's still this. This is based on human experience. These parameters are based on human experience, and they are set by humans. So there are probably patterns that we are missing. And if we would build a brain, if we would try build a brain that can find new patterns and new parameters in our data, just the way AlphaGo did, and teach us new things about the risk game, wouldn't that be amazing? I think so. Yeah, AI risk monitoring. So we have a feasibility study coming out, and see how this can work, if this will work at all. So yeah, we have a solid product yet, but yeah. So and we talk about a lot about user experience, for example, in fintechs, and which is great. But I think you need both. You need a good front end and a great customer journey, and a good back end to handle all the stuff that is coming at you from your great marketing and from your great platform, and people not defrauding you, yeah, through factoring, because maybe they figure out the parameterization and they figure out the loopholes on your thresholds, and then they only give you invoices below 10,000 euro. I don't know. Yeah, with this, the AI can learn to adapt to that and catch these guys potentially. Yeah. And then you can scale, because you can automate this risk process, because we all know, I mean, this is very costly to kind of monitor the smaller tickets, the smaller clients. Yeah. Well, and now decide for yourself if the robots are going to take over. Yeah, and that's the end. And I have 15 seconds, 14, 30. Thank you.